Hi guys, welcome back to this inventory video series. This is video 4. We're going to have a look in this video at how we can pass information into the inventory. We're going to focus firstly on setting up some code in the inventory widget blueprint itself. Just having a look at how we can start kind of passing in information from the pickups to the slot widgets within the inventory so that can show the correct images, the correct text, etc. etc. So let's start by just jumping into the inventory widget itself. What we're going to do is before we kind of jump into the code, we're just going to look at the item menu. We're going to look at its visibility and just set that to hidden. We're going to grab the toss single and also set that to hidden, and the toss multi and set that to hidden as well, just because we don't need them to show up when we load up the inventory itself. So let's just press compile and let's go into the graph. Now what we're going to do is firstly we're going to get rid of this event pre-construct and this event tick because we don't need those. The first thing to do is we're going to basically set up an array of our slot widgets. So at the minute inside our inventory widget, each of the slots exists independently, but we want to treat them as one object. So we're just going to click and drag these in just to get these first. So just drag them over. There we go. And slot 4 and slot 5. So once you've got those in, from slot 0, click and drag and just type in make array. You need to add pins until you've got the correct amount. So slot 1 can go into 1, slot 2 into 2, etc. And once that's built, we can promote the resulting array to its own variable, which we'll call slot array. And we're going to get that to there. And the next step is just to set some references to our player character and game instance. So we're going to use some cast functions. So the cast function basically is a way of checking whether an object that you specify is of the type of object you're expecting. So if we want to cast to the first person character, we get the player character from the game settings, and because we've set the first person character up in the game settings as the player character, we know that that will return the object that we're looking for. So we're going to promote that to a variable as well. Let's just call that one player. We're going to have another cast operation, which we'll call cast to my game instance. And again, because we set the game instance in the project settings, we know that if we get game instance, it will return the game instance that we want. So again, let's just promote the outcome of that to a variable. And we'll just call this one game instance. And once that's done, we're just going to select all of those, right click and just collapse nodes. And this is going to be setting references. So because we've collapsed it and we want some execution out afterwards, we need to make sure with this graph selected in the bottom left corner that we add a new output, which we'll set to an exec, and we'll just name that new port then. And we'll just click inside the setting references collapse graph just to make sure that we connect up the game instance set to the output, just to make sure that the execution continues through. So what we're going to do is we're going to firstly check if our actual inventory array, which we've set up in the game instance, is less than the array that we've just set up inside our inventory. The reason we're doing this is if our inventory in our game instance is larger than the inventory that we've specified in the visual inventory system, then that will tell us that we have an object in our inventory, which means that we need to get the information out to actually display it in the visual inventory. So to be able to do that, we are going to use a for each loop, which is going to allow us to cycle through an array and basically get some information about each element. So we're going to use the game instance reference that we set up before, and from the game instance we're going to get our own inventory. This is what we'll be comparing to. In terms of the for each loop, that's going to use the slot array which we just created before. So we're going to compare these two arrays together. So from the actual inventory, the data inventory inside the game instance, we're going to get its length. And the length is going to be compared to the array index of the for each loop. This will specify whether the index in the data array actually exists, and compare it to this one here, which we know always exists. If this one doesn't exist, if it is indeed greater than, then that means that it does exist, which means that we can start getting the information that we need. So from the inventory, we're going to also get a reference, and we're going to use the array index to supply which index we're getting. And we're going to break the item data out of the array get. So we're going to look at the array index from the inventory, and whatever we find there, we're going to break up into its component parts. So from the for each loop, each time we cycle through the array, we're going to set a variable which will hold a reference to the current array element. So we're just going to call this one slot reference. And from the slot reference, we're going to do our check to make sure we have objects in our inventory or not. So we're going to hook the return of this condition into the branch. So to set the objects, we now can grab our slot reference and we can get it. And if you just hover over the top of this, you'll see that what this slot reference variable actually is a reference to the slot widget blueprint, the original blueprint we created in the first video. Now, if you remember correctly, we created 3 variables in that slot widget blueprint. We created a pickup image, we created a reference to the name, and we created a reference to the current stack. So we can grab those 3 there. We're going to duplicate them so that we have another copy underneath, and just make sure that the slot reference is plugged into the target of all 3 of those as well. So the lower half is going to be left blank. That assumes from the false return that we don't have any items in our data inventory. So we don't need to set any of these images or text. But if it's true, if we do have an item in the inventory, then we need to set the pickup image from the data structure, we need to set the pickup name, and we need to set up the current stack. So that can come from the quantity. Once that's done, we can just compile that. And if we go back to the start and have a look, the event construct is the event which gets called from the very beginning of play. When this gets called, it will set the references up on the first instance and cause the first loop. But every time we pick up an object, we need to refresh this for each loop check. So with that in mind, from the exec node here, we're just going to create a new custom event, which we're going to call refresh inventory. So whenever we pick up a new object, this will be triggered and we will refresh from this execution path here. So once it's done, you can compile and save. And let's just jump over to the first person blueprint. Okay, so I've already messed around with this a little bit. The event begin play had all of the VR stuff attached. I've just deleted mine, and you can do likewise with yours. From the event begin play, we're going to create a widget, and this is going to be our inventory widget. We're not going to add it directly to the screen. We're just going to keep it in memory so that we can access it later on. So I'm just promoting the outcome, the output of that creating the widget, and we're just going to call it the variable inventory widget. In a space underneath, we're going to have a look at setting up an input to handle the widget blueprint actually opening and closing. So I'm just going to use the letter I. I for inventory, kind of makes sense. And when we press the letter I on our keyboard, we're going to want to alternate input between two values. So when we press I the first time, we'll open the inventory, and when we press I the second time, we'll close the inventory. So Unreal helpfully provides a node called a flip-flop node, which accepts one input and alternates between two outputs. So for output A, we want to make sure that we can see the widget blueprint. So we're going to get a reference to the widget blueprint first, and we're going to use the add to viewport function. After we've added it to the screen, we also want to make sure that the game is paused so that we can peruse through the inventory at our own leisure. To be able to actually interact with the menu, we're also going to need to be able to see the cursor. Now, the mouse cursor is a property of the player controller, so we need to firstly get the player controller. Once that is done, we can set show mouse cursor, and we want to make sure that it's true on the top line. Now for the alternate output, we want to make sure firstly that the inventory widget is removed from parent. This will not delete it from the game, it will just remove it from the screen, so it still exists in memory. We can duplicate these two widgets here, these two nodes here, by pressing Ctrl and W. We want to make sure that the game is set to be unpaused, and that the mouse cursor is set back to hidden. Make sure that you also hook up the player controller into the target. Now before we test this, we just also need to make sure that the input for the letter I is set to execute when paused up here in the details. If we have that unticked, we can open the inventory, but when we press I when the game is paused, the inventory will not close. So with that all done, just compile and save, and just give that a go in your game. If we press play and we walk around and press the letter I on our keyboard, you'll see that our inventory pops up. We can't click anything yet because we don't have any items, but you'll also see that the game is paused. So we'll wrap up this video here. That's basically the inventory kind of set up to a point where we can feed information in. In the next video, we'll have a look at using line traces to check that we are within range of a pickup, and then we'll have a look at the pickup object logic for a non-stackable object.